CIT 1123 Packet Tracer Instructional Video 2.4.11. And in this video, we're going to modify single area OSPF for IPv4, aka version 2. Pretty quick video, not a whole lot here. Two subjects. Number one, hello and dead intervals. Hello and dead intervals need to be set at the same rate for an adjacency to happen. So in order to have a neighbor adjacency, router interface has to have the same hello and dead interval times. If they are off, like an EIGRP, you can end up in a flapping situation. So OSPF just goes, yeah, you know what? If we can, when the packets get sent back and forth to build that neighbor relationship, if the hello and dead timers are not equal, we're just not going to form a relationship. And you have to figure out why that is, and that can sometimes just involve some show commands, looking at interfaces and identifying that you've changed the hello and dead intervals on one interface but not changed it on another one. The other thing we're going to do is use the bandwidth value and identify that OSPF is going to use the fastest path to a destination based on all the paths towards that destination. So we're going to run a trace route, and we're going to watch a path from PC1 over to web server. We're going to make a bandwidth change, reduce the bandwidth on one of the links, and then watch the path that the router takes change because the router believes that the path that it was taking previously is now slower. Okay, so that's really that's all we're going to do here. This is pretty good, pretty fast bid. In part one here, first thing we're going to do is go ahead and change that hello and dead interval. At this point, we're going to go to router 1 and we can check and see that OSPF is in fact running show IP routes, and we can see that we do have OSPF routes from our neighbors. And if we use some of the other OSPF commands, we could look at those like show IP OSPF neighbors. And we can see that we do have two neighbors here set up, and we are in a full state, so everything is as it's supposed to be. Now, let's go ahead and sabotage the system, as they say. Config T int s0/0/0, which is the link between R1 and R2. It's this link right here. We're going to go ahead and in there, and we're going to change these timers. When we change these timers, we're going to break that neighbor relationship between the devices. So we're going to change that, and let's do IP OSPF dead interval, and we're going to change that to 60. So it was 40 and 10, now it's 15 and 60. And in just a second here, what you're going to see is that adjacency is going to drop out because we're going to identify B or router 2 is going to identify that hey, the timers are no longer they're no longer synchronized. We're going to have to drop this connection. I'm just going to keep talking until that happens, which could be, I might have to hit the fast forward button. There it is. Holy cow. Okay, so the link is now down because the timers are off, and we only have one connection. Show IP OSPF neighbor. If we do this again, you'll see that there's only one link now. So the link to router 2 is in fact down. If we wanted to bring it back up, we can go to that specific interface in router 2, and we can change it to those same two values. So let's do that. So let's go to router 2. And you can see that it's in a down state. We'll do an config T int s0/0/0, and we'll do IP OSPF hello interval 15 and IP OSPF dead interval 60, and those are now set as they were, and that'll bring that link back up, and we'll be able to move on to the step 3 of this lab. Hey, that happened really fast, and you can see that there. Do show IP OSPF neighbors. I always like to check everything. I'm a big show command person, as you should be. So it says that it was work. I can see here that the link came back up. It says loading to full, which tells me that it is back up and running. But sometimes just doing an extra show command doesn't hurt, and this is a really short video, so no harm done there. All right, let's go now to PC1, and in PC1, what we're going to do is we're going to run a trace route over to web server, and we can watch the path that the traffic takes. So let's go here. And we are going to 64.100.1.2. And we're almost there. And there it is. Okay, and we've made our trace route. It's complete, and we've taken 4 hops to get from PC1 over to web server. Hop 1 over to router 1 to router 2 to the internet, router internet to web server, and that is our path, and that's what it's exposed to us here. Now the thing is, at this point, these serial links are all set to their default bandwidths, which is 1.544 megabits per second. But what we're going to do is, once again, sabotage the system, and we're going to take this link between router 1 and 2, and we are going to drop it down to 64K. At that point, router 1's going to go, man, you know what the best path is to get to router 2? The new best path is going to be this way through router 3. And we can take a quick look at it now. If we take a look at the routing table on this router, I'm going to do a quick exit. We'll do an exit again. Show IP route. We can see that the path that we're going to be taking is actually going to be the static default, which is good right now. Says go through 3.2 as being the best way to get to the internet. So we're saying traffic from PC1 hits the router, hits router 2, goes out to the internet. That's what we're saying, because 3.2 is right here. Okay, now what we're going to do is we're going to change the bandwidth on this interface to 64, and this path that we're using, it's going to change. This number is going to change from 3.2 to 10.6. I think it's 10.6 over here. Okay, so let's go ahead and do that. So config T and int s0/0/0, and we're going to go bandwidth and 64. That's 64K. That's really, really slow. You don't ever want to link that this is slow. Why are we explaining this to you? For a couple of reasons. Number one, you want to be aware of the fact that OSPF uses the bandwidth on the interfaces to calculate its metric values. Two, they want you to see that if you needed to change the default behavior of OSPF by lying to your routers, that is an okay process. That's something that you will do at times. So, all right, so that bandwidth value has now been changed. Let's start with the command line here. We're at 100%, so you can stop watching if you want. But we'll click on that, and you can see that the path has in fact changed, and the next hop is 10.6. Let's make it a little bit more exciting, and we'll do another show IP route, and we'll go do show IP route, and you can see that that path that we're using to pass traffic out towards the internet has in fact changed, and we're now going across 10.6, whereas before we were going across 3.2. That pretty much solves the mystery of lab 2411, so we'll see you in the next lab.